Good morning and welcome to the Green Ribbon Commission Climate Action Exchange. This morning, we're going to be talking about climate change impacts and projections for the greater Boston area. My name is Amy Longsworth. I'm the Executive Director of the Boston Green Ribbon Commission, and today's program is co-sponsored with ABC, A Better City, whose mission is to enhance the economic health, growth, and sustainability for all communities of Greater Boston. I'd like to acknowledge Eve Torrey, my colleague, ABC's Director of Climate, Energy, and Resilience, who is here with us today, and she'll have a few questions of the panel later on. We are recording this session, as you heard, and we're very fortunate today to have with us 6 eminent scientists, all of whom were co-authors on the report. And we have a lot to fit into an hour and a half. So here's what I plan to do. Introduce briefly the panelists, then co-authors Ellen Douglas and Paul Kirshen will give an overview of the report, a high-level overview. Then we'll open it up to the rest of the panelists, who each of whom is a contributor and a specialist in their field, and spend about 40 minutes in conversation. We have some prepared questions for them that we have designed to hopefully just really open up the topics, kind of frequently asked questions, so that you can sort of get the depth and breadth of what we're talking about here for climate impacts in the greater Boston area. And then around 11, we'll open up the chat. We'll look in the chat box. So please, if you have questions from the audience, please put questions into the chat box and we'll pull them out of there around 11. We're expecting really a ton of people. I see the numbers climbing as I'm speaking. We had something with over 200 registered. So we are going to try to get you all to as many questions as we can and try to ask the ones that we are seeing most frequently in the chat. Okay, well, great. And with that, let me introduce our panelists. Claire, do we have another slide here? There we go. So lead co-authors Paul Kirshen and Ellen Douglas are both Dr. Paul Kirshen and Dr. Ellen Douglas are both with the University of Massachusetts, Boston. Dr. Kirshen is an expert in complex interdisciplinary systems and has been very deeply immersed in climate studies in Boston for a long time. He was also lead author on the 2016 report, which was the first one in this every 5 years series. Dr. Ellen Douglas is a hydrologist, an engineer, an expert in the analysis of water-related issues. She also was co-lead on the project back in 2016. Dr. Rob DeConto is a professor of geosciences and co-director of the School of Earth and Sustainability at UMass Amherst. His background study includes earth science, climate physics, and glaciology, and he is really the sea level rise expert with us here today. Next slide, please. Dr. Ambarish Karmalkar is also with the Department of Geosciences, as is Dr. DeConto at UMass Amherst, and focuses on climate dynamics, variability, and change. And the main focus of his current research is to understand climate change in the Northeast and its impact on hydrological and ecological systems. Dr. Mathew Barlow is at UMass Lowell, where he's a professor of climate science, and his emphasis is on drought, flooding, and heat waves. And finally, Dr. Jayne Knott is an expert in groundwater hydrology and focuses on how climate impacts like rising temperatures, changing seasons, well, changes of season and sea level rise are affecting groundwater. So that is the tiniest little bio of each of these incredibly accomplished and knowledgeable people. I urge you to look them up. I urge you to download the report, which Claire can put into the chat if you haven't already done so. And without further ado, I will turn this over to Dr. Paul Kirshen and Dr. Ellen Douglas to lead us through a high-level view of the report.
Hey everybody, this is Ellen Douglas. Thanks for the introduction and thanks for all being here. We are going to lead you through what we can tell you about climate change impacts and related information over the next hour and a half. Next slide, please. So many of you may remember what we're calling the inaugural BRAG, or Boston Research Advisory Group report, that we released in June 1 of 2016. That was focused on Boston solely, looking at the 4 climate risks that we were really interested in back then, which was extreme temperature, extreme precipitation, sea level rise, and coastal storms. We found that not only was this very helpful to Boston, but it turns out that many, if not most, of the communities in Eastern Massachusetts, along with the coastal communities, were really using the information, because it was the first of its kind and the only report that really focused on, as best as we could, on Eastern Massachusetts and the Boston area. So one of the things that we recommended in that report was to update the science every 3 to 4 to 5 years, because this, obviously, climate change science is a very intensely growing and active field of research. And so the things are changing so quickly that we thought it's really important to update the consensuses that are presented in the BRAG. So as a result, we were funded by the Barr Foundation to create what we called the Greater Boston Research Advisory Group, which not only updated the Boston related information that was presented in the BRAG report, but also expanded the domain to include the 101 cities around Boston, called the Greater Boston Area, within the MAPC, the Metropolitan Area Planning Council domain. So we hope that the information now that has been released in the GBRAG report, which was released officially on June 1 of 2022, will be relatable and meaningful to Boston and the surrounding communities. So next slide, please. So Paul and I are going to give a brief overview of what's given in the report, and then each team leader is going to talk more details about their particular topic. So you can see there are quite a number of people involved. One of the things that we did very differently in the GBRAG was, the first thing we did was we went around to the communities within the MAPC region to find out what were the impacts that they were most interested in, most worried about. And so you can see that we have a stakeholder engagement and outreach team. We also have the 3 chapter teams, temperature, storms, precipitation, flooding, groundwater, and sea level rise, that are represented here. So we had a lot of expertise and a lot of engagement during the beginning and throughout this project. Next slide, please. So one of the things that we found was most troubling and meaningful to many of the communities is how climate change is going to impact precipitation, and as a result, flooding, either inland flooding or coastal flooding. So one of the things that we presented was an updated figure showing how design storms, so a design storm is just an amount of precipitation that is expected given a certain level of risk. For example, in this slide you see here, it's the 10-year design storm, which is on long-term average. the storm you would expect in a 24-hour period once every 10 years. So as you can see, those amounts are increasing from between 4 and 5.5 inches of precipitation in a 24-hour period currently, well, in 2000, all the way up to more like 5 to 6.5 or 7 inches by near the end of the century. And one of the things that we did, as I mentioned, we didn't just project and present information for Boston, but we also presented information from some of the long-term precipitation stations around the region. And so you can see that even though the amounts vary slightly, for example, Maynard has a slightly lower amount of precipitation in the 10-year design storm, and Hingham has a slightly higher, but you can see the slope of the increase is nearly identical for all of them. So all of these areas, the entire region is going to see an increase in precipitation, and Dr. Barlow is going to tell us more about that later. Next slide. One of the things that we found from our stakeholder engagement from around the community was that communities are really worried about the impacts of climate change on groundwater recharge. And I won't give any details about this now because we have Dr. Jayne Knott, who authored an entire special report on the impacts of climate change on groundwater. But there will be obviously impacts. We're already seeing those impacts on groundwater recharge and groundwater supply. Next slide. So I'm going to hand this over to Paul Kirshen, and he's going to finish off this overview.
Thank you very much, Ellen, and thank you all for joining us this morning. As we all know, extreme temperature is a threat now, and it's going to unfortunately grow in the future. We prepared graphs like this for the 4 counties in the MAPC area, the 4 counties of Eastern Massachusetts. And this graph shows several sets of information. First of all, the upper curve shows the change in the number of days greater than 9 degrees temperature we're going to see in the future. The lower curve also rising. The upper curve shows the changes under high emission scenario, the path we're on right now. The lower curve shows the number of days for a lower emission scenario. Perhaps if we got to, let's say, even if we went to a low emission scenario, perhaps even 0 emissions by 2050. I'll come back to that in a minute. But this shows right now for Suffolk County, Boston area, we have about 10 days a year when maximum temperature is greater than 90 degrees Fahrenheit. It grows in near mid-century to perhaps, depending upon the emission scenario, like 15 to 30. And by end of the century, depending upon the emission scenario, it could be 21 to 80. So in the higher emission scenario, the path we're on right now, by end of the century, essentially every day this summer could be like today. The other interesting aspect of this graph is it shows that pretty much no matter what we do to control our emissions, by mid-century, we're locked into, 20 or 30 days a year of days greater than 90 degrees Fahrenheit. It shows, though, by the end of the century, the actions we do now in terms of our controlling our emissions make a huge difference. If we do manage to control our emissions, we may only have an increase of 10, we may only have 20 days a year greater than 90 degrees. But if we continue in the path we're going, it's 80. So it emphasizes the importance of really getting the control, really getting a handle on our emissions of greenhouse gases as soon as possible. The other thing this graph points out, unfortunately, though, is even if you went to 0 emissions today, we're still going to have climate change in the future. So the most we can do right now is slow down climate change. Again, as I said earlier, if we went to 0 emissions today, because of the inertia of the climate system, we're still going to have to deal with climate change. but it's a lot easier to deal with 21 days as opposed to 80 days of days over 90 degrees Fahrenheit. This plot also shows days over 100 degrees, and that's the crosshatch. So right now, essentially, we have 0 days a year over 100. But by end of the century, we could have, looks like 50 to like 80 days greater than 100 degrees. So this just shows continued stress we're going to face from increased temperatures in the future. Next slide, please. Then this slide shows some of the environmental justice aspects of climate change. You know, all the impacts of climate change, unfortunately, impact some of the communities that are marginalized and oppressed more than other communities. And this is an example of extreme temperature. So on the left, you see essentially a heat map of the MAPC area of August 2020. And the colored areas are areas of high temperature. And then on the right, the colored areas are areas of where there are populations that have been marginalized or oppressed. And you can see there's a strong correlation in the colored areas. And so this essentially is meaning that these populations that have the least to do with climate change, because they tend to have the smallest carbon footprints, are going to be suffering the most from the impacts. Next slide, please. The next slide, this slide here, shows possible sea level rise projections for the Boston area. These are actually at the Boston, excuse me, these are actually for the Boston Gauge in Fort Point Channel. And this was the work of Rob DeConto, and he can talk a great deal about the complex analysis that went into these. But essentially, you can see, again, it's the same shape as extreme temperature, high emission scenario, low emission scenario, not much difference in 2050 in the range, but by 2100, a large range. So essentially, in a low emission scenario, we could have perhaps less than 2 feet of sea level rise by end of the century. High emission scenario, we could have like 4.5 feet of sea level rise. And above, the graph also shows that the high range for the BRAG report, which came out in 2016, instead of being the value here of 4.5, was actually 7.4. And that decrease came about because of Rob DeConto's and others' research into understanding the ice dynamics of the West Antarctic ice sheet. And Rob could talk more about that. But this graph also shows that the maximum plausible range in the 2016 BRAG report was 10.5 feet. Well, now the maximum possible range, because of this uncertainty, is now 15.6 feet. So while the sort of a most likely value has gone down compared to the 216 estimate, the most plausible maximum value has actually gone up. Next slide. I think that's all we have. Yeah, so I guess now we're going to turn it back to Amy for start of the discussion.
Thank you, Paul and Ellen. I wanted to kick off by asking you just, I've heard you both, everyone mentioned several times that there have been so many changes in climate science, what we know, what we understand, even since the 2016 report was written. So this report is different in a couple of ways. One is it covers a much broader area. Two is it looks at some factors like groundwater recharge we didn't look at the first time, but also climate science has gotten more sophisticated as I understand it. Can you just describe that a little bit?
Well, research is always improving, and one of the things that's always been one of the biggest uncertainties in climate impacts is related to how the ice sheets are going to be behaving from the warming ocean and the warming atmosphere. And so Dr. DeConto will tell us all about the latest information that his models are giving us, and also the observation. So not only has our science improved, but we have had 5 more years of observations, and we've been seeing some pretty drastic changes that even exceed the projections that we're making. So now the science is being backed up a lot by our observations.
Yeah, I certainly agree with Ellen. Seems like every month there are advances in climate science because of its very active collaborative research community. And as Ellen pointed out, we have more and more data to work from, being collected with more and more sophisticated instruments.
All right, that's interesting. And why don't we kick it over to Dr. DeConto, if you wouldn't mind just sort of talking about how what you found that was different. I know you were part of the 2016 study, and why is Boston going to be experiencing greater than the global average amount of sea level rise?
Thanks, Amy. It's great to be here. Yeah, so Boston is in an interesting place geographically in terms of where it sits on the globe. North America is still responding to the last ice age. So 20,000 years ago, there was a huge ice sheet sitting over Canada, centered on central North America. And that ice was so thick, it actually impacted the continent itself. It pushed down on the Earth's crust. And Boston is in a place where when there was a big ice sheet, the land was actually pushed up a little bit. So there was a big ice sheet over central Canada that pushed down on the Earth's crust. And some of the more viscous part of the Earth, the mantle, was actually pushing the land that Boston sits on up a little bit. So now the ice sheet melted. It has receded, 20,000 years ago to today. And the land is still responding to that. So the elevated land that Boston was sitting on is slowly settling and sinking in the slow recovery from the last ice age. So that adds about 1 millimeter per year to Boston sea level rise, because even if the ocean surface wasn't changing its height, the land Boston is sitting on would be lowering. So that increases what we call relative sea level rise. So that's one thing that Boston has going against it. Another thing that we all know when we think about the city itself is a lot of land that Boston sits on in terms of the city itself is so-called reclaimed land, and it's sitting on fill. That fill compacts over time. If that fill is made of things that decompose, like wood, timber, and old railroad ties and so forth, compaction can actually exacerbate this so-called relative sea level rise. So the first thing that we think about is the non-climate impacts of sea level rise. And Boston isn't in a great place in terms of that, again, because of this, these adjustments in the what we call vertical land motion, the fact that the land itself is dropping, and that makes it feel like sea level rise is going up. In terms of the future, Boston is in a bad place in terms of sea level rise if, and this is a big if, and we can get into this, and we probably will, I have a feeling, later in the discussion, if a lot of sea level rise in our future ends up coming from Antarctica versus other sources like the Greenland ice sheet or mountain glaciers, we are in a place geographically where changes in the Earth's gravitational field, and I'll come back to that in a moment, impact Boston in terms of sea level disproportionately relative to the global average. So we have ice, a lot of ice on Antarctica, a lot of ice on Greenland, the Greenland ice sheet. And if that ice that's locked up in those ice sheets melts and goes into the ocean, then we start to redistribute mass on the Earth's surface. And that, interestingly, impacts the Earth's gravitational field and even our pole of rotation. So these are planetary impacts. And geophysicists can do very detailed, now quite confident calculations on what the distribution of sea level rise would be if ice is lost from the Greenland ice sheet versus the Antarctic ice sheet. And they make these beautiful maps. And there's an example of one in the GBRAG report. We call these sea level so-called fingerprints. And you can look at a map and you can see where Boston is. And you can say, if sea level rises by 3 feet because 3 feet of ice was lost from the Greenland ice sheet, what does sea level rise look like in Boston versus an equivalent 3 feet of sea level rise that came from the Antarctic ice sheet? And it turns out that we have a lot less to fear from sea level rise that comes from Greenland. But if future sea level rise is dominated by ice loss on Antarctica, then Boston feels about 25% more sea level rise than the global average. So as the Earth in whole, in total, let's say the Earth sees a meter, 3 feet or so of sea level rise in the year 2100. If that sea level rise is dominated by ice loss on Antarctica, Boston would be feeling 1.25 meters of sea level rise. So that's why, Boston has a couple of things going against it. The fact that the land is going down, and we're worried about Antarctica because Boston feels this exaggerated sea level rise relative to the rest of the world.
And is there any way to predict whether it will be Greenland or Antarctica? I feel like I should be cheering for Greenland.
Cheering for Greenland would be really good for Boston and really bad for other places around the world. And so, Paul's already hinted at, some of the inequities in climate change. And, this is a really interesting area of research where people are actually looking at these issues. Communities that might be more responsible for carbon emissions might end up disproportionately impacting parts of the world that had very little to do with greenhouse gas emissions and the sea level rise in the first place. So, this is the focus literally of my career now, is trying to get a better handle and to reduce the uncertainty on the Greenland versus Antarctica story for exactly this reason. Right now, and this was the question really that you started this discussion with, the big source of uncertainty is not Greenland. We have more confidence in our future projections of how much sea level rise is going to come from Greenland. Antarctica is the huge wild card that drives the dramatic uncertainty in sea level projections that you saw in Paul's last slide. It's all Antarctica focused. And the reason why is that, number one, the Antarctic ice sheet is about 8 times bigger in its potential to cause sea level rise than the Greenland ice sheet. It's huge. The continent down there is bigger than the continental United States. The ice sheet is more than 2 kilometers thick on average across the continent. It could, if all the ice on Antarctica were to melt and go into the sea, the global average sea level rise would be close to 190 feet. So even really, really small changes in the Antarctic ice sheet will have really dramatic, catastrophic, essentially, consequences for coastal regions around the world. And we don't know exactly how it's going to respond to warming, mainly because the ice sheet is in contact with the ocean around most of its edge. And so the ice sheet is interacting with the ocean in very complex ways that are very difficult to develop, like computer models to simulate those dynamics between the ice and the ocean. So Antarctica is the big wild card.
All right, that is helpful. And a couple people in the chat are reminding us the news from Greenland is dire this week, and wherever sea level rise happens, it is affecting someone. So let me move on to Dr. Karmalkar to talk about heat and temperatures. I don't know if you want to take it from the angle of the Antarctic ice sheet, or just from the fact that we are sitting in the middle of a heat emergency today in the city of Boston. But if you could talk a little bit about your contribution to the study and particularly how it's going to affect our region, Boston and all four counties.
Thank you, Amy. Thank you all for being here. So I'll talk about temperature extremes. And the first thing I'll say is, I mean, in terms of surprises, one thing I'll say is that broadly speaking, there are no surprises when it comes to temperature projections. I mean, we've had assessments on global scale, climate assessments on national scales, state scales, and over the last few years, this is what we find. If the greenhouse gas emissions go up, then the temperatures will continue to rise. And the intensity and frequency of heat waves continues to increase. And that's what we try to summarize in this report as well. But there are a few things that we do in the report is just trying to refine these projections a bit better and make our projections more reliable. So we've done some work to understand how do we really grapple with uncertainties in climate models. We use climate models to make these projections, but there are issues with these climate models. So some of the work that we've done is to really carefully assess climate models to make sure that they capture the regional scale climate features that are important for the climate of Boston, and then use those models in our projections of the future. So you'll see in the report, we use about 14 different climate models. And then the next step is to downscale that information to really regional scales. So in terms of surprises, again, it's going to go, extreme heat is going to increase in the future, but we have a lot more confidence in the projections we provide. The other point I'll highlight is what Paul Kirshen talked about in his presentation is the importance of mitigation. And that's, the extreme heat is really one variable where you see the benefits of mitigation. Tomorrow we'll have a day that'll be about 95 degrees Fahrenheit in Boston. Typically in current climate, we get only about 1 or 2 days, if that, that cross maximum temperatures of 95 degrees Fahrenheit in Boston. But in a scenario where emissions continue to rise throughout this century, we will have as many as 50, 55 days, in the summer that will cross maximum temperatures of 95 degrees Fahrenheit. Whereas if we go with the medium emission scenario, then that number comes down to 23 degrees. And so it's really important to reduce greenhouse gas emissions. And so how these temperature projections materialize in the future really depends. It really depends on our actions in the future. And by the question is, how does global community respond to this, not just Boston or Massachusetts respond to this. So I'll stop there and then maybe talk about other things.
Let me just ask you one follow-up question quickly, and that is, all of this is about systems dynamics, right? So temperature is, the reason I went to you next is because we're talking about the ice on the South Pole melting around the edges, and it also affects groundwater. It also impacts ocean temperatures and storms and everything else. So how do you, I know you look at people and populations and social impacts, but you also are involved in systems. And where do you see, does temperature cut across everything equally, or are there certain relationships and variables that are dominant?
Right. I mean, so one thing our recent research shows us that the coastal parts of New England, which includes Boston, of course, the rate of warming is much higher than the other parts of the country, the other parts of the Northeast, and especially in summer, Boston area, coastal New England is only a small fraction of the entire Northern Hemisphere that has crossed 2 degrees Celsius warming so far. And so, you have to start thinking about combining that information with other factors such as human health. Summer temperatures, summer maximum temperatures going up. What does that mean for human health? What does that mean for energy demand? So these are some of the factors that one has to consider. But in terms of couple dynamics, what we find is that the reason why coastal temperatures are increasing at a faster rate is because they are also related to what's happening in the adjacent ocean. Many people must have seen the reports that the Gulf of Maine, the waters adjacent to the northeastern coast, have also warming at a much rapid pace, especially in the last couple of decades. There are changes in the ocean circulation, and that is resulting in sea surface temperatures going up. Now, of course, that changes sea level heights along the coast and has sea level rise impacts, but we demonstrate that is also affecting our coastal temperatures in the future, currently. And so the question is, if these circulation changes continue in the future and result in higher increase in ocean temperatures, then how will that impact Boston area? Now, it's not very easy to answer that question because some of the models that we use to be able to compute projected changes do not necessarily capture all those regional scale features. Much of the enhanced warming that we find along the coast shows up when we use high resolution observations. But when we use relatively coarse resolution climate model data sets, they don't really, capture that enhanced warming. So then the question is, I'm not suggesting that the projections we talk about in the report are necessarily underestimates, but when people think about using these projections discussed in the report, we should be paying attention to some of the worst case scenarios as well, because those can have higher consequences.
Thank you. I want to just, I want to get to Drs. Barlow and Dr. Knott, but I do think we need a clarifying question because it came in over the chat and I think it's a really good one. Would someone please explain the 3 emissions scenarios? What does that mean? Which pathway are we on right now?
Well, Ambarish would be, perfect person to answer that. But I was just this recurring theme that you're hearing from, I think, all of us about the importance of mitigating carbon emissions. And then I'll get to that question, that answer specifically. It's the same for sea level rise, of course. But sea level rise is really interesting. I think this is a really important highlight. In 2050, so, the next couple of decades, sea level rise is going to continue. It's marching onward. It's actually accelerating in Boston Harbor. So the pace of sea level rise is increasing. It's now about 5.5 millimeters per year. Okay, more than twice the rate averaged over the last century. But in the next couple of decades, sea level rise projections are pretty independent of emissions. We're looking at about a foot in Boston Harbor, regardless whether or not we follow a low emissions versus a business as usual high emissions trajectory. It's closer to the year 2100, a little bit later in the century, that we start to see this really dramatic divergence between low emissions and high emissions. And it's about double. So we stick with a high emissions trajectory. In 80 years, we're looking at least twice the sea level rise in Boston versus a low emissions scenario. Now,
so starting now, what we do now really matters because it amplifies over time.
Yep, exactly. And by the end of this century, it like doubles sea level rise, just as it really has this dramatic impact on the number of days above 90 Fahrenheit and so forth.
Yes.
So GBRAG looked at 3 different scenarios, and they're labeled in the report as RCP. Ambarish, we stuck with RCP, didn't we? Not SSPs. Okay. And this is standard IPCC, so United Nations Intergovernmental Panel on Climate Change scenarios. And there's a low and a medium in a high emission scenario. And the high emission scenario is a pretty extreme case where we assume that the world basically follows a fossil fuel driven economic growth model. And it's sometimes called a business as usual scenario, where we just go full steam ahead in extracting coal, oil, mix of natural gas with little advance in the percentage of renewables versus fossil fuel. So that would sort of be our worst case scenario. It is a feasible scenario though, nonetheless. So scientists have argued that there's enough available fossil fuel to drive that sort of greenhouse gas emissions concentrations. The low end, the lowest scenario that we looked at, the RCP, and the numbers are, it's technical, but there are numbers. It's RCP 8.5, 4.5, and 2.6. Low numbers are better because the low number is a calculation of how much extra energy the Earth's surface would be feeling from these added emissions. And the units are in watts per meter squared.
And
So
RCP is representative concentration pathway.
Exactly right.
So,
Okay, so the RCP 2.6, the low end scenario would be a world where in the year 2100, the Earth's surface would be feeling about 2.6 watts per meter squared more than pre-industrial.
so to put it in lay terms, if I'm a town planner for a town in Middlesex County, Massachusetts, I should be looking at this report and thinking, well, out to about 2050, 2070, these probabilities, I should be looking at the 8.5 high risk, high scenario and thinking, I've really got to have to deal with that realistically. Is that a fair statement?
You know, at least for the sea level rise story, you know, there are two things that our report provides. It's both sort of the background sea level rise projections and probabilities, so our best estimate, and then a range of estimates that include, you know, a range of uncertainty that those estimates represent. So on top of that, we provide, so if there's a meter of sea level rise, that would be the background sea level rise, and you can look at a simple map to get a feeling for what land area would be inundated. And then there's the issue, well, what happens if there's a meter of sea level rise near the end of the century and there's a big nor'easter? And if that big nor'easter occurs while there's a really extra high tide, then what does the map look like? And we provide projections and probabilities of how high sea level rise would be during one of those events as well. And if you were a planner, you would have to, I think, consider the value of a particular asset relative to these projections. And then, you know, you would have to be making very, very tough decisions about, you know, which are in part value-based, I imagine, as to what level of risk you are willing to tolerate for a particular location.
I can hear all 118 people on this call anxiety beginning to rise on that front. And I think thank you. I just want to make sure we don't run out of time for colleagues here. So that might be a good segue over to Dr. Barlow, who is our flooding, storms, and precipitation chapter expert. And do you want to just talk a little bit about what your key findings are? And one of the questions that I have is, you know, how can we be worried about flooding and drought both? And how do you even hold those two thoughts together as you try to mitigate or adapt?
Sure, thanks very much. So I'll just stress two things from our chapter. One is that the upper limit on the amount of precipitation, on the amount of rain we can get in, say, an hour or a day or 3 days, that upper limit is going up. There are lots of questions around precipitation and storms that we don't have very confident answers of, but that is one that we're very confident of. It's already happening. We have a theoretical understanding of it, and the models are in good agreement. So I want to stress that we're very confident that that upper limit is going to go up. How much it goes up is, as Rob and everybody has just been saying, that's really up to us. So that's that's the biggest uncertainty in almost everything we've looked at, is what decisions we make in terms of emissions. Is it a certain amount of increase is baked in, but whether it becomes sort of catastrophic or not, like with sea level rise and heat wave days, that really is up to us. So that's one thing I would stress, is that upper limit on rainfall or precipitation is going up, and we're very confident in that. And then the other piece, which also relates to your question, is that the variability is increasing as well. So one way to think about it is that I have a colleague who likes to put it this way: as it gets hotter, the atmosphere gets more thirsty. So when there's a lot of moisture around, if the winds are bringing a lot of moisture off the ocean, say, the atmosphere, the hotter it gets, the more that atmosphere sucks up that moisture and can just pour it out in really torrential amounts. However, if there's not moisture available, if the wind direction is such, say, that there isn't a lot of moisture incoming, then evaporation really takes over. You have a really hot surface, everything is really hot. I think we're seeing that, unfortunately, this week. And then things can dry out really quickly and really extensively. So it's possible to kind of whiplash back and forth between really heavy rainfall, say in the summer, and then a flash drought, a really rapidly developing drought. And I think over the last 2 years, we've seen that even in our region. Not as dramatically as, say, in the West, where they're in the middle of a really historic drought, but we've seen this whiplash. So that's, I think, the way maybe to think about that, hold in your head at the same time, that you can increase drought and increase flooding at the same time, is to think maybe of this thirsty atmosphere. The hotter it gets, the more thirsty the atmosphere gets. If there's water available, you're going to have big storms. If there's not a lot of moisture available, things are going to dry out really quickly. In terms, sorry, go ahead.
No, you go ahead.
Oh, I was just going to say, in terms of improvements on the precipitation side, things have improved. Our knowledge has improved pretty substantially over the last several years because, well, for two reasons. One is that every generation of computers gets faster. And the faster the computers you have, the more detailed a picture of the atmosphere you can resolve. So if you think about, I don't know, pixels on a computer screen or telephone screen, 3 generations ago, everything was kind of blurry with big pixels. And now we're headed towards kind of high def resolution of HD resolution of some of these storms. And the storms that create extreme events like heavy precipitation and flooding, in order to accurately resolve those, we need that kind of HD view of the atmosphere. And we're not quite there yet, but we're further along than we were in the last generation of computers and computer models. And as a result of that, the research has focused more on extremes. A generation ago, we were talking about changes in average conditions, which are very important, but maybe not in many cases as impactful as changes in extremes. And so now a lot of the research over the last couple of years has focused on that. So that really has allowed us to say more. And I'll just wrap up with a comment on surprise. I don't know that I was surprised so much on the science side of things, but excuse me, I am surprised that we're still struggling to communicate the urgency of the situation. So when I see these big floods that we've had, New York and Central Park set 2 records for hourly precipitation over the course of like 10 days. That's not surprising. That's what we expect. But when you talk about changes in terms of a few degrees or an inch or 2 of precipitation, the numbers, I think, don't completely convey the disasters that occur, the human impact, the infrastructure impact. So I'm still surprised that we haven't managed to get that across. And unfortunately, I'm surprised that we haven't taken more action on the mitigation side. We last time around was 2016. We've done a lot since then, maybe at the state level, but at the federal level, I'm surprised that we haven't done more.
Thank you. That's a very fair comment. And I'm really intrigued by the numbers not translating into the real impact, of course, until you're experiencing the real impact. And then you probably look at the number and think, oh, yeah. But getting people to anticipate is a very difficult challenge. Your work, stormwater and runoff and flooding obviously relates to Dr. Knott's work. I assume this is a question. Does it relate to her work in groundwater recharge? And, you know, I think groundwater recharge and its impact on potential impact on agriculture, which is crucial to our state, was not looked at in depth in the 2016 report. Now we've looked at it. So Dr. Knott, can you just give us an overview of what you found and what we should be concerned about?
Sure. Thank you, Amy, and thank you all for being here. It's my pleasure to be a part of this this great group and this great conversation. I would just say that groundwater tends to be out of sight, out of mind, and so we're a little bit late to the party. The groundwater hydrologists, we were not part of the BRAG study, and we're now part of the GBRAG study, and it's really great that I've come last here in this conversation, because we've heard about temperature, we've heard about sea level rise, we've heard about precipitation, and it all applies to groundwater, essentially. Groundwater is a complex system where you have precipitation, and precipitation rains on it falls on the ground, and aquifer recharge is the water that seeps down through the ground surface and recharges the aquifer, which is essentially the reservoir of water beneath our feet, and it sits between the sand grains, essentially sand, gravel, silt, clay grains beneath the surface, but it's water that we use. And aquifer recharge is very important for our drinking water supply. It's important for stream base flows. Essentially, at the end of the summer, streams are supported by the groundwater discharge to the streams. It's important for natural resources, and it's important for many other things. An example is the Boston Groundwater Trust in Boston looks at groundwater levels because they're concerned about the exposure of wood pilings beneath the buildings in Boston. And when the groundwater levels drop, those get exposed to oxygen and they decay quicker. So you might say, well, how does sea level rise have anything to do with groundwater? Well, right, very close to the coast, let's say within 3 miles of the coast, we're finding that groundwater will rise with sea level rise. So you're hearing me talk about groundwater levels perhaps decreasing, recharge decreasing inland, but at the coast, groundwater rise is driven by sea level rise. And so you have coastal roads that are affected by that. You have underground infrastructure that's affected by that. You can have water quality issues when groundwater levels rise into contaminated soils. Excuse me. So these are all questions that we talk about a little bit in the groundwater special report that is planned to be released fairly soon.
Can you talk about some of the practical aspects of changing groundwater recharge dynamics? Maybe, I know the impact on agriculture and perhaps a shifting of the cycle of the groundwater recharge is potentially significant. And then closer to the coast, it sounds like we should be rethinking perhaps the placement of infrastructure if groundwater is rising with sea level.
Right. So answering your first question about the seasonality of it, basically what we've seen in this study is that the annual average recharge rate inland will decrease over time, because essentially, yes, we've got increases in precipitation, but the increasing temperature and the increasing evapotranspiration outruns that. And evapotranspiration is the removal of water from the groundwater system. So when you have very high temperatures like we have today, the evaporation is much higher. The evapotranspiration, which is the evaporation plus the water that's removed by plants, is also greater. So as far as the seasonality of it goes, what we're seeing is that we're expecting more aquifer recharge in the fall and early winter because of the increase in precipitation. But in early spring, right through into the summer season, we're seeing a projection of a significant decrease in recharge. And that's because of a longer growing season, higher temperatures, more evapotranspiration, less snowmelt. The snowmelt in this region is important for us. When you have a snowpack and it slowly melts, the water seeps into the ground and it recharges the aquifer. If you have a heavy rainstorm, as opposed to, say, snowmelt, much of that water can get lost due to runoff, especially these extreme events that Matt was talking about. So let's see. You were asked about the sea level rise as well?
Well, I was asking you about practical implications, and I was suggesting that one that's further inland and then closer to the coast. If the groundwater is rising with the sea level rise, what does that suggest that we need to do about infrastructure? I mean, a lot of people in Massachusetts on septic tanks, for goodness sake. What is that going to do?
Correct. So when you have rising groundwater as a result of sea level rise, it's really not a big deal everywhere. It's only important in areas where the groundwater is already close to the ground surface. So when you have coastal roads where the groundwater is quite close to the base of that road, underlying layers of the road structure or the pavement structure, when you get a little bit of groundwater rise with sea level rise or more, the water actually goes into the supporting layers and it makes them weaker. And so you have roads failing as a result of that. So the idea, and the same thing applies to underground infrastructure, utilities, groundwater seeping into septic systems can cause groundwater contamination and the mobilization of contamination. You can get groundwater seeping into sewer pipes, which then go to the sewage treatment plant. And then you're treating groundwater as opposed to sewage waste. So it can cause all kinds of problems. And this is, like you said, Amy, this is really an adaptation problem. So the first step would be to find out in your community where the vulnerable infrastructure is. And then you can take measures with respect to roads. For instance, you can plan your maintenance program to take into the account that groundwater will be rising and you need to support your roads better. Rather than repaving it the way you've always done it for the last 30 years, you might do something different. You might have a thicker.
Okay, that's super helpful. I think I'm assuming a lot of folks are digesting sort of, well, what does this mean in practical terms that we need to do for a town, a neighborhood, a city. So it's almost 11. Thank you all for just giving the overview of your work. I know this could probably be a 7-day conference rather than a 1.5-hour webinar, but we're going to do the best we can. And I'm going to start pulling questions now out of the chat box. And I will kick my first question over to my colleague from ABC, Eve Torrey.
Thank you, Amy. I appreciate that. And thank you to everybody. You know, it's really interesting to see the kind of changes from the 2016 data, not just in the updated findings, but also like how it's going to affect a much broader region than just the city of Boston. So thank you for all that you're doing. I guess my first, my main question, I do have a couple of others if there is time. The first one is, I know you're all experts in your particular field, but you've come together for this report. So what new or updated findings did you find that were most impactful or of most concern, and why? Like the ones that we should be screaming from the rooftops kind of findings. And then what recommendations do you have for how they should be integrated into climate policy, both at the city and state levels? And this is for everybody, if that's okay.
So a foot of sea level rise in just 2 to 3 decades means that, you know, places that now are experiencing like a storm flood every 100 years, well, that same storm flood is going to be happening every decade. And the 10-year events are going to be happening almost every year, right? So I think that should be something that I would scream about in terms of like planning now. We have to plan now for what sounds like a modest amount of sea level rise, but it will exponentially increase impacts, like in terms of the number of flood events. And then, of course, you know, having a longer term perspective and starting to have to consider these really more dramatically more extreme scenarios and the possibilities that Paul showed on his concluding figure during his presentation are, again, you know, if there's even a small possibility, a 1% possibility, and I think about, you know, would I get on an airplane that had a 1% possibility of crashing? And here we're saying, you know, it's the 99th percentile outcome, a 1% chance of a sea level rise being this high. But that still could be potentially, you know, very consequential, very, very high impact, even though it's low probability. And the magnitude of these sea level rise projections would mean the kinds of infrastructure commitments that we would have to start planning for now. So we've got the shorter term, 1 foot we're going to have to deal with regardless. And then in the longer term, we have these really scary possibilities that are going to need us to really start thinking and investing and working with engineers to figure out how to deal with this now.
I'd like to follow up real quickly on that. I agree entirely, and I'm thinking of Paul's earlier slide about vulnerability, the most vulnerable populations. And I think what we need is a much greater sense of urgency. But I think as we're thinking about these adaptation solutions, in addition to mitigation and in addition to reducing emissions, but as we think about how we're going to have to respond to what's going to happen no matter what we do with emissions, I think it's important to think about what other problems we want to solve. So we have to change infrastructure. We have to reduce energy usage, but there are a lot of other positive outcomes that we can wrap in with that. There are other problems we can save. We can make more efficient housing, which is less of an economic burden on our most vulnerable populations. We can have more green spaces. We can increase the health of our population, especially our most vulnerable population. So I'd just like to throw out there that while there's a large response needed for this, it can also solve a lot of other problems. It can be an opportunity, not just a societal burden for that. So I'd just like to emphasize that as we think about it.
That's a great reminder. Thank you for that. I think that in Boston, that is the fundamental philosophy behind the mayor's Green New Deal is that more than one problem can be solved, and it must be solved at a time. So on that front, a question from the audience is, how do you think we can do better in communicating the nature of the uncertainty and the risk to the public, given the lack of probability and statistics understanding? How do we convey the urgency, in other words? Or how do we understand the risk, given that most of us are not statisticians? And then how do we convey the urgency to the public and policymakers?
So I've been thinking about that question since I saw it on the chat, and I think people don't realize or forget that we all deal with uncertainty in our lives. For example, anybody who commutes to Boston for work has to make decisions under great uncertainty. And depending on the impacts, you're going to estimate how much time it takes to get to work. For example, if you have a meeting with your boss, you're going to take into account the fact that Boston traffic is not only highly variable, but can be extremely slow. And so you're going to estimate at the high end to make sure that you get to work on time to meet your boss. Whereas if you're just going on a normal day, you might have it's lower risk, therefore your estimate's going to be lower as far as your travel time, and you're willing to take the risk of being late. So I think that dealing with climate change is a similar thing. We always, nature has always been variable, and we always have these extreme events, but humans have worked really hard to try to keep our lives at some level of constancy. And in doing so, we've actually enhanced the variability of nature and the unpredictability. So I just wanted to remind people that we're always we always make choices under uncertainty. We just kind of forget that because we hope that things are constant. So just thinking about if people think more deeply about some of the choices they have to make, for example, when to go on vacation. If you decide to go into the Caribbean in the middle of hurricane season, and you neglect to think about the fact that there could be a hurricane that disrupts your plans, then you're going to be very disappointed. So we all have to think about uncertainty, and now we have to sort of take the blinders off that we've created in our society, that life is constant, and realize that there's a lot of uncertainty in our future that we need to plan for. And it's just Carl Spector, who used to be in the city of Boston, he said something a long time ago that I thought was very telling. He says, actually, scientists are the only people that are honest about uncertainty. Everybody else sort of pretends like we don't have uncertainty, but scientists are the only one that have quantified that uncertainty for people to see. And so we just have to accept the fact that we have these risks and the uncertainties and try to absorb it as best as possible.
Can I add that I don't think we should underestimate the public's understanding of climate change. I mean, Ellen and I and all of us have worked all over the world with all sets of populations, and so-called normal citizens, they understand the nature of the threats we're facing in the future if they're carefully explained to them. So again, I would not underestimate the capability of the population to understand these threats. Yeah, go ahead.
Yeah, I'd like to jump in if I may, Amy, and just mention that another way to deal with uncertainty is to really to focus on a particular asset that you're interested in. So we talk about the top-down approach versus the bottom-up approach, or hybrid approaches. So the top-down approach would be to pick an emissions scenario and try to design your asset or your infrastructure to that emission scenario. The other approach would be to take a look at that particular asset and say, under what conditions will that asset fail? And you look at it from that perspective. So you understand your asset and you understand what the temperatures might be, or what the groundwater levels might be, or what the precipitation might be. But at that point, you basically have a deep understanding of your asset, or you have a deep understanding of your agricultural product, or you're the expert. And then you can make informed decisions based on the vulnerability of that particular asset for different climate situations.
That's the other end of the grabbing it from the other end of the handle. Can we relate that back to what Matt was talking about with this solving multiple problems, or giving people a sense of something to work toward rather than something to shield ourselves from or run away from, and how that might make a difference in addition to what you just said, Jayne, with the tangibility of thinking about a particular asset? Like what are some ways that you've seen from working all over the world that other cities have done that, have moved towards something positive as part of their climate change solution?
Paul, I'm hoping that you can talk a little bit about your work with Ellen on like nature-based solutions to resiliency that end up having enormous co-benefits to the local ecosystems, to local economies, to serving environmental justice communities in a positive way, that contribute to mitigation through absorbing carbon.
Well, I think Rob just said it all right there. And as Matt brought this up, there are tremendous co-benefits associated with adaptation. In fact, many of the things we think about for doing from adaptation to climate change should be done even if there was not climate change. So for example, we should be making our cities greener. We should be making our coastlines more accessible. We should be restoring coastal habitat. And even if there wasn't climate change. And if we do all those things, we're certainly going to improve the quality of life in cities. And by the way, if we do them well, we'll also make the cities resilient to climate change. And so, for example, along the coast of Boston, we can actually implement green infrastructure. The elevation will protect us against the flooding. On the coastal side, there'll be habitat, which help us restore ecosystems. And the green space on top of these green systems will provide cooling, will provide open space in a lot of the communities like East Boston that do not have a lot of open space, where there's huge social inequities. So I'm sort of coming around to believing that the co-benefits alone, even without the climate change management aspects, are going to make a lot of the actions we want to do to manage climate change extremely attractive to the public. I think that just got to be explained. And this applies also to managing extreme temperature, extreme runoff, and so on. And also I want to point out that this is going to require sophisticated planning to do this adaptation, to deal with the uncertainty of the impacts. But essentially, every dollar we invest in adaptation may reduce future damages by 5, 6, 7, or 8, 10 times. So it makes a lot of sense economically. And also, we really need to invest in adaptation planning. It's only going to cost millions of dollars, whereas adaptation to build all the things is going to cost us billions of dollars. So we should really have to think about, we really have to apply good planning techniques to deal with adaptation, so we don't actually result in some cases we make it worse, maladaptation. But the investment in planning is certainly worth it. We've got to keep that in mind. We shouldn't nickel dime on that.
So this hits directly on a question that came in on the chat. I'll just read it verbatim. Your regional approach is encouraging. Would it be helpful to create a statewide MWRA type authority to coordinate research planning and resources going forward? This is obviously your opinion, but what do you all think? I think that's basically saying, can we have a climate authority? Would that help?
Well, I think in my opinion, I think supported by other people here, is that some actions to deal with climate change in terms of adaptation are very, very local, and they may be municipal or even the household level. But some adaptation actions require coordination across political boundaries, and the incentives to take them obviously cut across political boundaries. So we need a body to think about that on a statewide level. The same thing with mitigation. In the new climate bill, I guess 10 communities want to limit gas hookups, no gas hookups in their community. And so should that be across the community? Should that be across the state? We also have a statewide building code, and that's going to be updated as well to make it more responsive to climate change. So, and also financing is a real complex issue. How do we finance this? So just not the wealthy communities are controlling the greenhouse gas emissions, or having good adaptation. So those are good reasons I see for some sort of a czar of adaptation.
Other thoughts here? Because right now, financing is one department or agency, infrastructure is another, et cetera. Housing is another. I know this is something the Green Ribbon Commission feels strongly about establishing. We haven't really talked about it so much statewide as citywide, but I think the thinking is the same. Anyone else
Yeah.
have?
So I'll jump in just with a short comment, piggybacking on what Paul said when he was talking about nature-based solutions. Hydrologic boundaries are almost never political boundaries. So since these are issues that affect water, in many cases, a regional approach really makes sense, so that you can work with nature in a more efficient manner, as opposed to thinking about it in terms of political boundaries.
Before we went live this morning, I had asked you all a question, so maybe I'll just open that question back up. In the light of the very long list, Joe mentioned Supreme Court, et cetera, where we are not getting leadership at the federal level, we're not participating multinationally. The United States isn't, unfortunately. Is it possible for cities and states, these much smaller units of government, to actually knit ourselves together into something capable of addressing the problem? Or are we looking at a case where Boston solves many of its problems through innovation and the green leadership we've been talking about, and nevertheless, in the face of the bigger problem, which is global and systemic, as you all have brought forward here today, what can we do? And I think there were some really thoughtful discussions. Maybe you, Matt, in particular, had a thought about that.
Yeah. So I'll just pitch the sort of determined optimism here, which is that, or at least I'm determined to be as optimistic as I can. I think that individual cities, municipalities, the state can do a lot in the short term to dramatically reduce emissions and to work on adaptation. So I think that there's a lot of progress that can be done. I don't think that we can really make the progress we need to make without national, international efforts. But I think actually individual cities and states can do a lot. There are a lot of efficiencies that can be done, energy efficiency. There are a lot of programs. You can increase public transport. So there's a lot that we can do. And my hope is, my determined optimism is that if we provide that leadership, if we make those positive steps, if we show that the changes we need to make can have really positive impacts on a lot of problems, then that will be a way forward. If nothing else, you can show that you're saving a lot of money, then other states that may not be politically inclined to do something may be financially inclined to mirror what we do. I think California also is interested in being a leader. That's one of the top 10 economies in the world. So I think at the state level, there is a lot that we can do. And my hope is if we do that at the city and state level, that will really galvanize efforts at the higher levels.
One thing I'll add is that we were talking about different emissions scenarios earlier, and in terms of current emissions, we are no more on the worst case emissions trajectory. We've actually moved away like a little bit in the right direction. So our emissions are not rising as fast as put forward in that worst case scenario. So that tells us something about market forces helping us move in a slightly better direction. And somebody brought up wind in Texas, right? There is a lot of wind energy generation in Texas, just because it makes financial sense. And so one bit of optimism is that some of those financial mechanisms might help us actually move away from the worst case scenario globally, not just locally.
Is that at all pandemic related data, or is that independent of?
That's independent of
Okay.
pandemic.
That's interesting to learn. Someone in the chat has asked about a price on carbon. Not sure if that has been discussed yet. No, it hasn't been discussed yet. I don't know really what the question is. I don't know that there's politically any hope for a price on carbon, but we do have the RGGI scheme. So there's implicitly, in some ways, in New England, a price on carbon. But have you all been thinking from a political or practical point of view about that argument or that effort?
Well, I'm no expert. I would just say that that seems to be one of the levers. And we probably need to exercise every lever that we can. I think that's harder for a state to do, for instance, than say providing a state tax discount on heat pumps or something. So I think at the state level, aside from something like the RGGI regional agreement, that's pretty hard, but it's, I think, one of the levers, and we need to push on every lever that we can.
What are some of the, when thinking about carbon makes me think about all these carbon sequestration innovations that are beginning to emerge in different forms. And I want to ask you all about innovation in your respective fields. What do you see either from a research innovation perspective, or what do you see from an innovation perspective that might actually work toward mitigating some of the impacts? Is there any, what are you seeing out there that's exciting?
I don't want to dominate the conversation, but I do want to make two quick comments on that in terms of technology that I hear mentioned a lot that I think is not a good innovation. One is carbon dioxide removal, which is a technology we need to think about and invest in, but currently is not, can only remove a few seconds worth of emissions for the whole year. So I think we need to, there are a lot of technological innovations, but we need to think carefully about how quickly they can be implemented. And the other is so-called geoengineering in terms of trying to put sulfate aerosols into the stratosphere to reduce the amount of sunlight. Those are, as Rob is indicating, and I'm sure we're all on exactly the same board, those are really awful technological interventions. So there are great things that technology can do, and there are really awful things that technology can do. And we need to be very careful. In terms of technological innovations, I think, Ambarish has already mentioned renewable energy. The cost of renewable energy has just plummeted, and that's fantastic.
So Ambarish offered a glimmer of hope, and I see that it's been picked up on in the chat. But I don't want to be a downer. It is true that we are heading in a better direction. But okay, so you all know about the UNFCCC, the United Nations Framework Convention on Climate Change's Paris Agreement, which was updated in Glasgow last year. And I've been participating in these meetings. The goal of the Paris Agreement is to limit global warming to 2 degrees, no more than 2 degrees Celsius relative to pre-industrial climate, but with the ambition to try to keep global temperatures from rising by 1.5 degrees Celsius relative to pre-industrial. We're at 1.2 degrees warmer already, and the clock is ticking. To meet the Paris target, we really would have to be trying to achieve like net zero emissions globally. This coordinated international approach that Matt was talking about is really where we ultimately do need to go, by mid-century, which is that's like really dramatic cuts, like starting tomorrow. And one of the reasons why we're worried about, okay, so all the nations in the UNFCCC have signed up for a voluntary reduction in emissions by some certain amount. And if you add up all of those current policies, if all the nations actually followed their defined so-called nationally determined contributions to these reductions in emissions, we would warm by about 3 degrees Celsius by the end of this century in 80 years. And what we're worried about is that there are a lot of aspects of the climate system where that is just too much. That puts us into a territory where we start to risk really big changes. And sea level rise and the loss of ice from Antarctica is one of them, where we start to go into that really high, impact, maybe low probability, but still, risking something really, really terrible happening. So, that's the perspective. The current policies aren't good enough. We have to do even better. We should be, all trying to support the Paris Climate Agreement. But, another thing that Matt alluded to, and he's absolutely spot on, it goes back to those like 1980s bumper stickers, the whole think globally, act locally thing, right? They were all over Boulder, Colorado when I was in college. That's it. Here's an example. UMass Amherst campus has absolutely committed to being net zero in terms of its operations by 2032, 1 decade. And if that big public serving institution, without the cushion of a huge endowment is able to achieve that, that sends a really powerful message, and it provides a roadmap. It can be done. And now look at the benefits. Look at the training that the students got while this was happening on the campus. Many co-benefits. And again, this, are doing something in our own local municipalities, hopefully coordinated at the, state level. This Northeast Greenhouse Gas Consortium is another step in that direction. You ultimately team up the Northeast with California, you have a big fraction of the United States economy. And I think things will hopefully start to steamroll from
build
there.
it up piece by piece. So one last question I'm going to ask from the chat, and I think this is a great question, we haven't really touched on it, is New England has 33 million acres of forests. Do the panelists agree that maintaining forest cover and doing what we can to ensure nature's carbon capture options stay healthy is an important regional action? And I know that's a big part of the Clean Energy and Climate Plan. Was that in the report, really, the carbon absorptive? Okay.
Obviously, it's very important. And it also has incredible co-benefits in terms of, recreation and ecological benefits and so on. So obviously we want to maintain as much of our natural systems as we can.
Yeah, and I think it's worth emphasizing for those who don't know, New England was, Massachusetts especially, mostly deforested 150 years ago. So I think we were down to something like 15 or 16% forest cover. And then over the last 150 years, we massively reforested, which is great. But over the last 20 years, I think 20 or 25 years, we've started deforesting again. So I agree that it's really, we need to keep those forests, but we also, it's become a more critical issue in the last few decades. We've started going the wrong way again with different development options. And that's maybe to go back to, I can't remember if Rob or Paul was saying the importance of this kind of statewide and region-wide planning to get at those kind of issues.
Including
Also,
solar, for example, out here, so not in Boulder, Colorado, but here in the Pioneer Valley, the bumper stickers I see are, we need forests and we need solar power.
Right.
So like PV replacement, but we offshore wind, we have such great potential resources in offshore wind development. We're in that way, very, very well positioned.
Yes.
We've also got to save our marshes and wetlands as well. They're equally critical.
All right. It is 11:28, so I want to start to move us toward wrap up. This has been great. There is a lot of hope here, a lot of urging to accept and recognize realistic risk, but there's also a lot of hope here. Actually, frankly, more than I thought going into this session. So thank you all for that. So Dr. Paul Kirshen, Ellen, doctors, that just applies to everyone. Okay, Paul Kirshen, Ellen Douglas, Rob DeConto, Ambarish, Karmalkar, Jayne, Knott, and Matt Barlow. Thank you all so much. And Eve Torrey and ABC for co-sponsoring this webinar. It will be recorded if you can, watch the highlight reel in a couple of days. Claire will get that out. And I just have one more slide I wanted to show you that I asked Claire to quickly make while we were talking, because I realized that one of the projects of the Boston Green Ribbon Commission, which is called Action Pact and involves artists and cultural institutions to try to talk to the public about climate, that we have this image of David Ortiz, Big Pappy, right now on Lansdowne Street on the side of Fenway Park. The Red Sox were very gracious in helping us do this. And there we are in RCP 8.5 in 2070. He's playing in 2 feet of water. So on that note, thanks again to the audience for being great participants and to the panelists. And we do not currently have another scheduled GRCx program, but we will have one and we will let you all know. And we'll see you again then. Thank you.
Have a good weekend, everybody.